Hello sir, hello everyone. This is to me Mr. Prosper, and I'm taking you through this assignment about question one, which is about the fork fundamentals. Yeah, so basically I'll go through the implementation part of this question, and you can't go through the implementation when you don't know the theory part. Yeah, of course, if you talk about the fork function in C, it is a system call like used to create a new process. Like when a process calls fork, the operating system creates a copy of the calling process, including its memory space, the open files, and carrying the execution date. Yeah. So the new process that is created is called the child process, and the original process is called the parent process. So both the parent and child process continue the execution after fork, but they have separate execution contents and independent control flow. Yeah. So that is the basic information that you should be able to know about the fork. Yeah. So after knowing such information, yeah, we go to our code so that we can somehow implement some of it. Yeah, it's like since I'm offline, it's like I'm unable to use the repread, which is an AI tool. So I decided to use the dev C++ like for implementation. Yeah. So to go through the code, this code basically implements like shows how on how you can go about using the fork function. Yeah. So that first line, of course, it is a preprocessor directive that includes standard input that defines functions like printf and pass error. Then the one of types, the one of types, uh, that one specifically defines data types for system calls, such as PIDT for process identifiers. Then the one of weight, it defines functions and macrons for waiting for the child process to terminate, yes, like using the wait function. Then the one of unstd, yeah, it defines constant constants types and functions for various system of services such as fork and and get PID. Then the ODIB basically it's for memory management and exit functions. So after knowing such, we go to our main function, which is the entry which is the entry point for the execution. Yeah. So after then we define some variables, that PID, that is variable declaration that defines a variable named PID, yeah, which is an integer type. It can store the process identifier. Then we go to the one of fork, like yeah, uh, the one of fork, it is a function assigned the return value of fork. Yeah. So the fork function creates a new process that is a copy of the calling process as we have had before, and returns the process identified the child process and to the parent process. And the sort of goes to the child process. Sorry for that. So if the function fails, it returns -1, and we shall consider almost all those conditions using the conditional statements. The if, yeah, like if it is less than 0, you know that there is some error. You print that error using the pass error. Then you exit immediately. Then you go to our else if, of course, if it is equal to 0, uh, uh, it means this is a child process. Yeah, specifically. Then that's what we want to print. Like if that child process, then we print, yeah, we print this message to the terminal somewhere. Then if it is successful, you exit with 0. then lastly we end with our else statement. Of course, our else that's basically will mean that it is a parent process. Yeah, it means that it is a parent process. So our that print function, it is another of course function code that prints the formatted message, the standard output stream. Yeah, of course using the print function basically. So you can print these messages. Yeah, that as you have had, like if you're in the parent process and you print the get PID. If you're in the parent process and you print the PID, yeah, so it will give the process ID of the child. And if you print like yeah, then you go to that wait function. Of course, that is a function code that makes the parent process to wait for the child to terminate and ignores the status value of the child process. Of course, that wait function returns the process identifier of the terminated child process, or -1 if an error occurs. Yeah, then we return result like if the process terminates successfully. Yeah, so this is my first code, and to show you the output, let me go to my Ubuntu and I just run it. Let me press my ls. Yeah, so to compile, of course, you use the GCC, then you specify GCC, then specify the name, which is question one. Let's see. Then you give it a name like one something. Then you run it. Yeah, if it runs successfully, it will come like that. Like if it doesn't, it bring some other messages, and you run that one that you have created. Yeah, so that is my output. Yeah, as you have seen, the first one is the parent process, which is created first, because yeah, and the second one, it is a child process. And this, of course, this parent process, it is the one that is under, like after you have used fork to create, and you somehow print in the parent process, and you print the return value of fork, it will print this PID. Yeah, so that was my number one, and I tried to do number two also. Let me first show you the question. Yeah, so question two, it is talking about the pipe communication, like explain the concepts of pipe and their use in the interprocess. Yeah, so for last year, basically implementing the code, which is implement a C program that uses pipes to achieve the following. The parent process sends a predefined string message to child process. The child process receives the message and prints to the console. Modify the program to enable bidirectional communication. The child process sends a response message back to the parent process. The parent process receives and displays the response message. Yeah, so this is pipe communication. So basically for me, I try to implement a C program that demonstrates the use of pipes for interprocess communication between a parent and a child process. So pipes are a method, of course, of IPC that allows processes to exchange data through file descriptors. Yeah. So a pipe has two ends. You have to know this. It has a read end and a write end. One process can write data to the right end and the right end of the pipe, and another process can read data from the read end of the pipe. Yeah. So our pipes are unidirectional, meaning that data can flow in one direction. So to enable, of course, if you want to enable by direction, you need to use two pipes, yeah, for each direction. So yeah, so to go through the code, I try to go through the code line by line. Maybe you can understand well. Yeah. So as I had discussed about these libraries, I won't repeat. Maybe those ones which I didn't talk about, the string. The string, which is another, of course, it is another processor directive that includes the string header file, which defines functions and macrons for string manipulation, such as, of course, strlen for length, then strcmp, like many of those functions. Yeah. So basically, that's uh, uh, the lib that we didn't had in the last code. So maybe let's jump the main. Let's jump to the main code. Yeah, of course, that is at the entry point for execution, that main line. Then we go into the defining variables. Yeah, so begin with that PTC, which stands for child to parent to child. Yeah, parent to child. So this is a variable, of course, declaration that defines an array of two integers named PTC, which will be used uh, which will be used as file descriptors. So this will act as our file descriptors. Yeah. So we go to the one of C. Yeah, we define the one of CTP. Of course, it is another variable declaration that defines an array of two integers named here CPT, which will be used as file descriptor for the pipe from the child to parent, of course from child to parent. The other one was parent to child. And we also define the PID using the PIDT data type. Yeah, PID data type. Of course, it is another variable declaration that defines a variable named PID of PID data type of an integer type that can store process identifiers. Yeah, so that one is the specifically process identifiers. Then afterwards we go to that character. Yeah, it is not a character, it is a string. Yeah, a string. So this is another variable that defines an array of characters named msg1, which will be used as the message to parent, as parent to child. Yeah, parent to child. Yeah. So we also define that message down. It is, of course, it is another variable declaration that defines an array of characters named msg2, which will be used as message from child to parent. Then we also go to that character. It is another variable declaration that defines an array of 100 characters named buffer, which will be used as a temporary storage for the messages. Yeah, so we go to our that conditional statement. So that conditional statement, basically, those are conditions like when those file descriptors fail to run. Yeah, so this is, of course, it is a conditional statement that checks if the creation of either pipe fails. Yeah, like if those pipes are fail to work. So the pipe function, of course, takes an array of two integers as an argument and creates a pipe with is a file descriptor stored in an array. Yeah, the pipe function returns 0 on success and -1 on error. Yeah, you have to consider that. Then we also consider the pass error. That pass error, like of course that will be printed like if it has failed to work. And of course, if it fails to work, you have to exit with 1 here, like if prevent your program from not running. So afterwards, of course, you create with fork function. Of course, yeah, that one is a system call, and that assigns the return value of fork to the variable PID. Yeah, as we have had the last time, like the fork function creates a new process that is a copy of the calling process and returns the process identifier of the child process to the parent process and 0 to and 0 to child process. Yeah, so if it fails the function, it returns -1. So you consider those factors, like if it is less than 1, if it is less than 0, you know that it has failed. Then you print that error using the pass error function, and of course you exit the function. Then you go to the else if. So else if that one it is greater than 1, so it means that is a parent. Yeah, it means it is a parent process. So of course, if you get into the parent process, you need to do these basic things first, like cross PTC that we declared up as our parent to child. Then specify that arrow of 0. So that function call crosses the file descriptor PT0, which is the read end of the parent to child process, and a child to pipe. So the cross function releases the file descriptor so that it can be reused by other files. Yeah. So you also consider that you also cross the CTE, the child to parent process. Yeah, you also consider that the child. Yeah, it is, of course, it is another function that crosses the file descriptor, a child to parent one, which is which which is the right end of the child to parent pipe. Of course, the cross function raises the file descriptor so that it can be reused by other files. So after doing such, we write the parent to so that write statement, it is another function code that writes the message MSG, the file descriptor p, which is the right end of the parent to child pipe. Of course, you need to be knowing the basics of write function. You know that the write takes the 3 arguments, that is the file descriptor to the to write to, the buffer to write from, and the number of bytes, of course, the number of bytes to write, of the number of bytes written on success and -1 on error. And that's string length. Yeah, this function, this one, it returns the length. It returns the length of the string excluding the null terminator. Then that +1 is added to include the null terminator in the message so that the child process can read properly. Then we consider that wait function. It is another function that makes the parent process to wait for the child process to terminate and ignores the status of the child process. Yeah, so after doing that, we go to our read. Yeah. So that is another function code that reads the message from the file descriptor cpd, which is the read end of the child to parent process and stores it in buffer. The read function takes 3 arguments. You have to be knowing the basics of read. The file descriptor to read from, the buffer to read into, and the number of bytes to read. Yeah, so the read function returns the number of bytes read on success and -1 on error. Yeah, so that size of operator returns the size of the buffer in bytes. So afterwards we print. So this is another function of code that prints the formatted message standard output stream using the print function. Yeah, so the message contains the string parent received followed by the content of the buffer, then followed by the numeral character. So that then afterwards, after that print function, you close. Of course, this is another function code that closes the file descriptor, which is the right end of the parent to child pipe. Of course, it is used so that it can be reused by other files. That's why it is used. And afterwards, you also close the child to parent. Yeah, it is another function of code that closes the file descriptor, which is the read end of the child to parent pipe. Yeah. So afterwards, of course, you need to consider the ls part of our code. Yeah. So our ls code will start with closing the parent to child. Of course, that one is another function code that causes the parent to child, uh, which is the right end of the parent to child pipe. The close function releases the file descriptor so that it can be reused by other files. So you also close the child to parent. Child to parent. Of course, it is another function that closes the file descriptor, which is the read end of the child to parent pipe. Which is of course like that. So afterwards, you need to use you have to consider also the system call, like to read. So this is another function code that reads the message from the file descriptor, which is the read end of the parent to child pipe and stores it in buffer. So the read function takes 3 arguments that we have had before. The file descriptor, read from, the buffer, read into, and the number of bytes, and returns -1 when it is in error. So you also print that message. Of course, that is another function code that prints a formatted message to standard output stream using the print function. Of course, that message contains the string child received followed by the content of the buffer followed by the new line character. So afterwards, you also use the write system call. So this is also another function code that writes message to the file descriptor, which is the right end of the child to parent pipe. I will not repeat like what write it contains, but you need to know that the write function of course returns the number of bytes written to on success and -1 on error. So you also close. After doing that, you close the parent to child. that function closes the descriptor PTC, so the bind to child, and they also close the child to parent is another function that closes the descriptor. So after doing such, of course, we exit with 0. Or it terminates the child process with status 0, indicating successful execution. Then return, of course, that function. After you returning 0, it means you're done with the code. That is the end part of C programming. Yeah. Of course, it indicates the successful execution. So maybe I can run my code. Maybe you can see its output as it is question 2. Let me give it a name, something like 2. Yeah, now it has run successfully. For me to run, I use // then 2 executable, that is will be the executable file. Yeah, so our program is successful because we wanted to send messages, to exchange messages between the parent and child, and it was successful. Hello from parent and hello from child. It means our pipes work successfully. So maybe if you go to question 3, it is talking about message checks and chat application. So part B, it is talking about implement a simple chat application using message checks. Create 2 processes, a sender and receiver. The sender process allows users to input messages and send them to message check, and the receiver process is continuously receiving messages from the check and displays them. Yeah, so for me, I try to implement this code, of course. Yeah. So message checks are a method of IPC that allows processes to send and receive messages through kernel managed check. Yeah. So that is the basic description of message check. Of course, each message has a data type and content, and processes can select which messages to receive based on the type. Yeah. So for me, it's like I'd created some code. I will take you line by line. Question 3. Yeah. Now you see there are some libraries that are added, like for you to implement those message checks. Yeah, we had talked about the STDI, that one I want to read about. The standard lib, I want to read. Then maybe if you have to talk about the sys /IPCE, this one, list, that one is new to us. So it is another process, of course, the directive that includes the system IPCE header, which defines the data type and constants for IPCE, such as the key _t, for IPCE keys. Then if you go to that MSHE, so this of it is another processor that includes the system message checks header file, which defines the data type and functions for message checks IPCE, such as MS get, MS SND, many of those functions. So I try to go through line by line, like our So this is a type definition that defines new data, named message T. This one, this one, message T. course that contains two fields, m type and message. The m type field is long integer that represents the message type, and the message field is an array of 100 characters that represents the message content. This data will be used to store and send messages through the message check. Then afterwards we go to our main function, which is the entry point for execution. Then we use that key t. This is the data type, then we call it key. Yeah, so this is a variable declaration and assignment that defines a variable named key of data type tt, which is an integer type that stores IPC keys. So the key is assigned to the return value of a fdoc function, which generates a unique key based on a file name and character. The file name is given as that dot, which means that the kind directory and the character are given as a. The fdoc function returns a keys on success and negative one on error. So we go to that int msg. Yeah, so this is another variable declaration and assignment that defines variable named msg id and that of data type integer, which is an integer type of code that can store message checks identifiers. The ms is assigned to the return value of the msget function, which creates or gets the message check with a given key. Of course, the msget function returns a message check identifier on success and negative one on error. So we go to those if statements. Yeah, like if it is negative one, that msg function has failed. Then we use the pass error function that prints the error message, the standard error extreme. Yeah. Then of course after receiving that error, you exit with 1, which terminates the process with a status of 1. Then afterwards, of course, you close and return 0. Return 0, indicating of course is successful execution. So this is the code I tried to get, like for me to implement those message checks. Yeah. So to show you the output, I need to first compile. It is question 3. So for a mid run, you use // then 3. Oh, maybe I got some errors. I will try modifying it. Maybe I can make it perfect. So to go to question 4. It is talking about the concept of shared memory and its use for sharing data between processes. That was part A. Then implemented C program that uses shared memory to achieve the following. The parent process creates a shared memory segment containing an integer variable. Then both the parent and child processes can access and increment the shared variable. Then part C is talking about extending the program to include the synchronization mechanism. Yeah, the semaphores specified to avoid the race conditions and ensure consistent update of the shared variable. Yeah. So to give a basic description about those shared memory for interprocess communication between the parent and process child. Yeah. So shared memory is a method of IPCE that allows processes to access a common region of memory to read and write data. So this method is fast, of course, and efficient, and it requires synchronization mechanism to avoid inconsistency and race conditions. Maybe I will take you through the code line by line for you to understand better. That was question 4. Yeah, so those are basic libraries. I described those that I knew. I talked about the IPCE library, so I won't talk about it again. Maybe I will talk about the C/SHM.H. It is a processor directive that includes the system shared memory header file. Of course, it defines the data structures and functions for shared memory IPCE, such as the SHM get, the SHMAT, yeah, those basic, the SHM, then CTL function, yeah. And if you talk about the one of types, yeah, it includes the header file which defines the data type for system calls. Yeah, we had talked about that one. We had used it earlier in our earlier program. Yeah, and that one of 8 we had used, and that one of the UNSD had used. Yeah. So we go on describing our code line by line. That of course that is the entry point for execution. That mean uh, uh, and also describe the key. The key underscore is the data type. Then the key is the variable name. Then ftop sh file, yeah, 65. So this is a variable declaration and assignment that defines a variable named key of data type key type, which is another integer that can store IPCE keys. So the key is assigned the return value of fork, which generates a unique key based on the file name and character. Yeah. So we also like declare that one. Yeah. So it is another variable declaration of course assignment that defines a variable named sh of data type integer, like which is an integer type that can store shared memory segment identifiers. Yeah, so the shmd is assigned to return value of shmget function, which creates or gets the shared memory segment with the given key. The second argument of the smget function specify the size of the shared memory segment, which is set in the size of an integer in bytes. And the third argument of the smget function specify the required shared memory segment flags, such as the IPCE create, which creates a new shared memory segment, yeah, which creates a new memory segment. And if it does not exist, and if it does not, and that 066, it sets permissions, of course, for the of the shared memory segment to read and write for all users. Yeah. So we start on considering the if statements. That is, of course, a conditional statement that checks if the value of smd is equal to -1, which means the function has failed. And also consider the pass error, like if it has failed, it shows the error that made the function to fail. there, of course, after you exit, you terminate your process. You terminate. Then after you go to that end, it is a variable declaration and assignment that defines a pointer variable named shared var of data type integer, which is a pointer to an integer. So the shared var is assigned to the return value of the shmat function, which attaches the shared memory segment identified by the shmd to the address space of the coding process. Yeah. So we also go to that if statement. Like this is another condition that checks if the value of the shared memory is equal to void, then some asterisk minus 1, which means that the shm function failed. Yeah, that was it mean. Then of course afterwards you exit with 1, and afterwards you close. Yeah, so we got that statement that begins with asterisk shared var equal to 0. That is an assignment statement that assigns the value of 0 to an integer pointer by the shared var pointer. This initializes the variable to 0. Then we also consider the fork. It is of course another variable declaration and assignment that defines a variable named of PID of data type PID, which is an integer type that can store the process identifiers. Yeah, and it is also assigned to PID. Then you consider it's like if it brings some errors, that means when it has failed. It checks for that -1. You know that when it is -1, you know that it is an error. Of course, if it is an error, you exit with 1 function. Then you also check for else if statement. This is another function that checks if the value is equal to 0 specifically. Of course, if it is equal to 0, it means that is a child process. That's what it means. Then we also consider our for loop. So this for loop, this is a for loop that iterates from 0 to 9 with a loop variable named I of data type integer, which is an integer type. Then if you go to that var, this is an increment statement, of course, that increments the value of an integer pointer by the shared var pointer by 1. This modifies the shared variable in the shared memory segment. Then afterwards you print is that print statement. Yeah, of course, after you printing, you need to use the sleep condition. Yeah, so this it is another function of course that makes the child process to sleep for 1 second using using the sleep function. Yeah, so this sleep function takes an argument of unsigned integer, which is unsigned for integer type, and returns the number of seconds left to sleep interval. Then afterwards you close and you go to shmd shared var, this one. It is another function code that it detaches the shared memory segment from the address space of the child process using the smd function. So basically this is my code. Yeah, you see the else statements, the what, use the basic knowledge that I've shared with you up to continue with these statements, and you end up with end of the. Then for me to run this code, I go to my Ubuntu and I just compile using the GCC. Then it was question 4. Then 4. Then I run. For me to run, I use /, then 4. Yeah, so you see, our process has run successfully, and which that is what we expected. Yeah, so basically, this is what I tried to research about. For question 5, my other colleagues will try to work on it if possible. So, thank you, sir. Remain as to MIMSE prosper. Computer engineering.